Hello everyone, I welcome all of you to this class. In today's class, I will discuss how machines learn and how to estimate parameters if you are studying actual science. So who can attend this class? Those who are studying mathematics, statistics, actual science, data science, AI, data analytics, or anyone who is studying statistics who have started learning linear regression. This class is going to be very crucial, not only for understanding, but also to develop the concepts in right way so that you will be able to apply whenever it's required. So if you see in the practical world, when it comes to applying for a job, they want to see whether you know the concepts and whether you can apply to the practical situations or not. Theoretical learning won't be helpful for you, whatever you study. Understand what is linear regression, what is the meaning of estimating the parameters, what is the meaning of the machine learns. I mean, I will take a separate class to differentiate between an actuarial science student and a data science student in terms of what they are supposed to study and learn. Although both are converging, actual science is where it's tried and tested. Data science is where we are exploring. Actual science is normally model driven and data science data driven. So that's where you need to know what is the meaning of machines learn in linear regression that you will learn today. Also, let me take this opportunity to say something because people always talk about AI. Roughly, you can understand. I mean, I would like to say in one line. I'll take a session for this. What is data driven? What is model driven? Everything you will be able to know in depth. But today's class is dedicated towards linear regression fundamentals. Up to 2005, normally we get data and we analyze Excel kind of data. However, these days we analyze not only Excel type tabular data, the numbers are there, but also image data, text data, video data, time series data, spatial data. So now it's multimodal. So you must learn many methods, right? That's where there is a concept of actuarial data scientist, where not only you are supposed to learn actual science, but also you need to upskill because data science concepts and this AI now, it's making a web, generative AI and agentic AI. So yeah, it's used everywhere. But yeah, I'll give a special class for that. Let me continue with this one. Now let me share my screen. See this one. This is something and I generated this. I didn't write a single line of code. It will be useful for you in today's class. You see this. Now how machines learn. How you get the line which will be very close to the points. Now, let me go to the board. These points are given to you. You are requested to find a line which will be very close to the points. The best line in the sense, the line is overall, I can say, close to the point. This could be one line. Suppose you don't know any programming language, you don't know calculus, you don't know mathematics. Okay, manually, you can get a rough line. This line, this line, what you need to check? You need to check whether this line is close to the points overall, I mean, total error you will find, or this line. Okay, so what you can do is you can rotate and you can take parallelly. That way you can do. I'll show you first. I will come back to this one. Yeah, that was good. Let's keep this. It looks the best line of best fit. Let me go here. You see, this is Desmus graphing calculator. Here you see what I need is I need a line which will be very close to the points. So how can I achieve it? So first of all, remember, we need to slide the line or we need to rotate the line. Here, if you see, either you need to slide the line. So that means your y-intercept is changing. You go on sliding the line, the angle remains the same. Then you rotate the line as well. You rotate the line. So the rotation means what? The slope of the line will change. When you talk about rotation, when you are rotating the line, the slope of the line will change. Suppose this is the line of best fit, y is equal to alpha plus beta x, 3 plus 2x, say for example. Now when you rotate the line, this will change. When you rotate the line, This will change. When you slide the line, this will change. That's what I will show you. So by rotating and sliding, you will try to get the line of best fit. Why we want to get the line of best fit? Yeah, that we'll discuss, okay? And we'll derive the formula also in today's class. How to estimate alpha and beta. This is our goal. Y is equal to alpha plus beta x. So points will be given. You need to put the points. I mean, you need to take the points and estimate alpha and beta. That's what we'll do today. This is the first class, as I said you. When you go to the distribution of data, that should be the second class. So I'm not going in depth, but yeah, I will be at a conceptual level. Now let me go here. See how I'm rotating the line, you see. I will change this one, 2 to 3. See, the line is now, if you see the angle from this angle to x-axis, you get the slope. Now you change 4, you make it 5, you make it 6, you make it 7, you make it 8. The line is rotating. Okay. Now let me make it 2. I started with 2. How about this? 3. Now I'll make it 4. See, it's sliding. The y-intercept, this 0 to 4 here, 0 to 4 here. See, y-intercept is 4 here, 0, 4, right? So now I'll make it 5. Now see, y-intercept will change 5 here, 0, 5 if you see, but the angle remains the same. Okay, if you want a 45-degree angle, I will make it 1. 1. This is 45-degree. How about y-intercept? I will make it 4. I will make it 3. I will make it 2. I will make it 1. I will make it 0. Then it will pass through origin. So what will happen is you can always rotate the line and you can parallelly slide the line. That manually we can do. So if you are doing manually, probably you might be needing 10,000 times, 20,000 times. Every time you need to check the error, it will take a lot of time. So we do mathematically. It used to be when programming was not there through mathematics. Then when C programming came, I remember I worked as a faculty long before that time. In mathematics class, there was a lab. No, that was engineering. So we use C programming. I started with C programming, then SAS, SAS, then R programming, then Python programming since 2017. Everywhere we are using. So before programming, before mathematics, you had to do manually. Now mathematics came. I will derive today mathematically. No programming is required. Just do it mathematically. We will use least square estimation. Using least square estimation, we will be able to achieve that. But if you write a program, again, it will be very easy. Okay. I'll do the derivation part also. But before going to derivation, remember, we are finding sum of square errors. Okay. I mean, if you have question why square errors, you try to get it from somewhere. If you don't get it, ideas are not clear, you ask me in the comment, I will definitely answer. There is a problem. So we try to find the sum of square errors. Okay. I'll take you to that animation also. Now, this is one error. Okay. If I write this point, this point will be my x1, y1. This point will be x1, y1. This is my sample point data. I collected data. This is my x2, y2, and this one x3, y3. This is x4, y4. So someone who must be pursuing a course in data science, what they say is, they say machine learning. Machine learning means machine will learn. How it will learn? AI is mathematics ultimately. Coding for implementation. So machine will learn alpha and beta. That way manually you fix the line, then definitely you will get alpha and beta, because to define a line, to describe a line, you need to know alpha and beta. I remember I taught back in 2018 or 19, one student asked me how machines learn in linear regression. I said it's equivalent to estimating parameters in statistics or actuarial science. He was like, I never studied actuarial science or statistics. I want to know. I said to him, did you find the line of best fit mathematically? I mean, did you already run the program? He said, yes, I run the program. I got the values. I asked, what are the values? He said, my values are 2 plus 3x. alpha and beta. I said in one line, machine learned 2 and 3, that's all. In actual science, in statistics, we say estimating parameters. Is there a difference? Yes, there is a difference, but yeah, 90% the same. Because as I already mentioned you, in actual science statistics, our goal is to understand more about the modeling part. We'll do hypothesis test for the parameters. We'll try to understand more and more. We'll find residual. We see whether the distribution is proper or not. Why? Once you join any company, you'll be able to know uh, you are doing anything. What will happen is there are so many parameters, they will change. Okay, whatever you work, wherever you use. Okay, in pricing or wherever you use. Okay, if you change one, how it changes, you want to observe, because it's very, very crucial. You will be able to interpret it. However, in case of machine learning, the assumptions are less, it's mild, but the main goal is to predict for the new data. So what we do is we divide the data into training and testing. Okay, there is a different way, those who didn't study, because my goal is to derive today and I'm focusing on actual science. I'll not go to that way, but remember, we are doing the same thing. You do it through R programming or mathematically or use Python programming. We are doing the same thing, but the goal is different. The assumptions are different. In statistics, we are more interested in the model. Okay, of course, we also predict, but in machine learning, we upload the data without checking for the distribution part, all that. Normally, many do, though that is also required at a deeper level. But coming to neural networks, artificial neural networks, they're, much less assumptions, okay, because it will learn from the data automatically. There is a different learning from data automatically means it's different for different algorithms, different models. Here, coming to linear regression, it's just getting the best values of the line of best fit. Best values in the sense, if this is the line of best fit where overall square error is minimum. Square error means what? Square error means this multiplied by this. If you make a square here, okay, what will happen? Multiply this by this. Okay, that is square error. You make a square here. So you find the areas. Okay, for this line, you have this area. For this line, you will have a different. See, my error is this here. So I have to make a square. If I use another ink, say for example this, I have this line. Okay, so I will have this area, squaring. Similarly, for all point you have to find. Anyway, I'm not making it complicated. Now here in the animation part, you see here, I will run it. If you see here, it's pixel means the total areas. Okay, the area means what? We're squaring the errors. Okay, so this area is minimum. You see, once again, see, this area is minimum. Even if you go here, if you run this, see, it's rotating. In this animation, first it rotated, then simultaneously both will happen. So finally, the line will be fixed. We'll take this line. This is called trend line. This is a linear one, linear regression line. Linear regression in the model means what? Linear in parameters, not linear in variables. Okay, suppose you get an equation y is equal to 2 plus 3 x square. That also will consider because it's linear in parameters. Because x square part, you can take another variable. Okay, so when you go to correlation, that way x square is another variable, say z and y. You see they are correlated or not. That's what we check. However, in linear models, we see whether the parameters are linear or not. When you talk about linearity, there we check whether variables are, y, when we say y is 5 plus 6x, x and y correlation, when you find correlation means what? There is linear relationship, no square, cube and all that, right? Even if it's there, it will be considered in linear model. So our goal is to find this. Same. Now we'll go to this one, understanding part. So now this square error, suppose I've already fixed this one, y is alpha plus beta x. Let me erase this one. And now mathematically I will derive. Those who are doing for the first time, from whatever subject you are, you need to know the derivation. It's very, very important. I should know this point, then only I will be able to know this error. Okay. This is one error. This is one error. This point I know x1. And if I say my line of best fit is alpha plus beta x, of course it will be beta x1, because this x1 you put here, you get the value of I, because this is the equation of a line. This point will satisfy the equation of a line. If you find the error, suppose this is E1, and I'm writing total sum of square error, okay, E1 square, x1 minus x1 square minus x1 square 0. So y1 minus beta, here I will get y1 minus beta x1 square, the first error. Then you find E2, then you find E3, then you find E4, like that up to En you have to find. If this is nth point, let me change to n. So instead of writing each one, I've written beta y1 minus beta x1 whole square, okay, summation. So this is sum of square errors. We'll try to minimize. What is our goal? Estimate alpha and beta in such a way that m is minimized, the sum of square errors. Okay. So you have to find those alpha and beta for which we get the line of best fit. In other words, now to estimate alpha and beta, we need to differentiate with respect to alpha. We need to differentiate with respect to beta. Remember, I'm not using MLE. You can use MLE also. For that, the assumptions will be required. I'm doing by least square estimation. Normally, we don't use MLE here. When you go to GLM, we use MLE. You differentiate with respect to alpha, it will be 2 summation yi minus beta xi square. With respect to alpha means alpha coefficient. There is no alpha, right? How there is no alpha? Y is alpha plus beta x. Achha, I left alpha here. Beta x1. This is also wrong. Okay. So let me write alpha plus beta x1. Similarly, this point also you write, this point you write. So alpha plus beta xi square. So this will be alpha plus beta xi. Alpha differentiation is 1, but minus is there. Then differentiate with respect to beta equal to 0. These two equations you need to solve. That's all. If you differentiate with respect to beta, coefficient is minus xi. So xi you need to multiply. This will be xi yi minus, you multiply xy, alpha plus beta xi. This is 0. You need to solve these two equations. That's all. It's mathematics. Okay. Because if you don't know the proof, 5-line proof, always you will have doubt in mind. Now let me solve this one. So the first equation, if I remember, that was summation yi minus alpha plus beta xi. Summation alpha plus beta xi. And the second equation, summation xi yi summation alpha xi, because I have taken yi this side. Okay. So alpha will be here plus xi you have to multiply beta xi square. That's all. So then you can find the summation here. That will be summation yi. Here summation alpha will be n alpha. Summation starts from 1 to n. Then beta summation xi I is 1 to n. Here you will get summation xi yi. Here alpha summation xi plus beta summation xi square. You need to solve and find alpha and beta. That's all. It's so easy, right? And that's what, when you use some programming language, automatically you will get answer. Behind this mathematics you will have for sure. Let's solve this. To solve these two equations 1 and 2, I will take these values. Suppose I will take this is a, and another variable, this is b. This one I will take c. B is already there. This one I will take d. That's all. So a will be equal to n alpha plus beta b. I need to solve for alpha and beta. That's all. You think that a and b are two numbers. And this equation, I will take, as I already mentioned you, C alpha summation xi. I have taken already b, so I will take b. And then beta summation xi square, I have not taken d. So you need to solve these two equations. That's all, 3 and 4. To solve these two equations, I will multiply this by, because alpha b, I don't need alpha now. N is here, b is here. I will multiply with b. You multiply with B. And here alpha, N alpha, B alpha. So N is not here, right? You multiply with N. N alpha B plus beta D N. That's all. I multiply with N. Now you subtract. If you subtract, what will happen? This term and this term, they will get cancelled. You will get finally, if I am subtracting this from this, I will get NC minus AB. NC minus AB is equal to, you take beta common, alpha n minus B square. So once I get beta, see I got beta here, beta is equal to NC minus AB divided by alpha n minus beta square. Now what you can do is, you put the values of ABCD. If you put the values of ABCD, you will get something like this. Beta will be equal to, if you remember, I have taken C summation xi yi minus A, I took summation yi, then summation xi divided by alpha. I got alpha. Strange. It was wrong. It's not alpha. This got cancelled, right? So this will be how I got alpha here. I multiplied with n. So it should be n beta. So beta dn. This is not, acha, this is d only. Okay. So this is not alpha. This is dn. What is d here? D I took for summation x square, if I remember. D I took for summation xi square. Okay. N summation xi square minus b square. B, I think I took summation xi, if I'm not wrong. Yep. Summation xi whole square. So you can remember whatever x1, y1 you get, you just put here, you will get beta. Once you get beta, because we already accepted that our model is y alpha plus beta x. If you already get beta, if you want to remember, you can remember this way, xy. So there is an expression, you can use that as xy by s xx as well, or directly you find beta. So finally you write beta estimated. So y will be equal to alpha plus beta estimated x. So once you know beta, you will be able to know alpha, right? Because this is the line of best fit. So what will happen is, once you know beta, you will also get alpha. There is no problem. I will utilize this for how I will write. I will write y bar is equal to alpha plus beta x bar. And then I'm not finding the expression whatever way. If you know alpha, then you find beta. That's all. Alpha and beta are estimated. Let me go here. Machine learns means mathematics runs through this, and finally it shows the visualization. That's a separate thing, but you like get the line of best fit. What is the benefit of getting the line of best fit? Okay, that's what you need to know here. Let me erase all some questions here. So you think on these questions. Probably I will leave you with the questions. The first question here is, you think on this if you are studying, because 40 years you will work in the company minimum, right? So this will be there. This is the starting of modeling. Many, they forcibly apply linear model, but the data, if the data, I mean the points are not close to the line, how can you apply a linear model? There is a square relation. That is the difference between, when you ask me correlation, uncorrelated independence, what is the difference between that? So if you write y is I square, I'm not talking about linear model parameters. When you write y square, so if you take a lot of points, I mean minimum 5-10 points per exam, not a lot of points, you will be able to know that the link is not linear, right? In x and y, it could be sine x, it could be log x. This is not linear. You write plus 2, 5, whatever. They are not linear. Okay. So we'll not try to fit a line. You need linears. For that, you need to check R. If R is very close to 1, then we can go for a linear regression. Otherwise, we have so many models. Okay. Even we'll go to GLM. But again, GLM assumes distributions. Okay. Exponential family of distributions, like here also in the latter part you see, we need the distribution, normal distribution data. If the data is not normally distributed, will not take this one. Okay, apart from that also, even if the data is normally distributed, if you don't have a high correlation, then also will not take. So try to learn those. Also, this is not the population regression line. This is sample regression line because we found from a sample. But what about, suppose you are saying something for the society as a whole, the population strength is 50 lakhs. You have taken a data of 100. Is this your real regression line? No. So you have to test for everything, for alpha, for beta, whole lot of things are there. From sample correlation, also from X bar we go to mu. Similarly, from R you have to go to rho. Suppose you are finding correlation between two variables. This is the population correlation. You are saying for all. So you need to test a hypothesis. You can find the confidence interval. For that, you need the data distribution. So here in linear regression, data distribution is normal. Okay. So all those things you have to know the three assumptions of linear regression. You need to test for alpha and beta hypothesis test, and for R at least. And remember we are talking about the sample. When we talk about this one, we are talking about the sample. When you talk about rho, this is population. You can compare this way, mu and X bar. If you get a sample, then you can estimate mu. Like if I say, find the link between height and weight. If you take 10 students, you apply R formula. What is R formula? Sxy divided by Sxxyy, whatever formula you have. If you apply this formula, you find R. That is a sample. You can take a sample of 100 students, actual science students they are studying. You find R, but how that will be useful? Anyone can do. Someone who is studying 10th class also one can do. So what you are extra studying here? So you have to do something for rho, okay, for the population. For population parameter here in regression we take rho. You have to, sorry, in correlation you have to go to rho. You can never get rho. You can never calculate rho. You can only estimate. If you can calculate rho, nothing to study. If you can calculate mu, nothing to study. If you can calculate for sigma, nothing to study. So everywhere in CS1 we do these things. Yeah, I mean, as I mentioned you already, this much for today's class. See you next time soon. I'm leaving now. Thank you.